Hello everybody, so today's video we are going over how to find the sine, cosine and tangent of right angle triangles, or sine, cos, tan, the namesake of this channel. To get it? Sine, cos, dan, sine, cos, tan. It's like funny because my name is Dan and it's short for tangent, so I said sine, cos, dan. Anyway, so today we are calculating sine, cosine, and tan. So we're going to be calculating sine, cosine, and tan from a given right angle triangle. And then we are also going to be calculating sine, cosine, and tan, etc. from a given trig ratio. So if we're given a sine, cosine, or tan, we're going to calculate the other two from that. So first things first, I'm the realist. And then the second thing is we need to understand what sine, cosine, and tangents are. So these are called trig ratios. These ratios above me here, these only work for right angled triangles, or right angle triangles. So what is a right angle triangle? Well, it's a triangle with a right angle. You know what I mean? So if we look at here, so sine of an angle is equal to the opposite side over the hypotenuse. The cosine of an angle is equal to the adjacent over the hypotenuse, and the tan of an angle is equal to the opposite over the adjacent. So let's have a looky here. So I have a triangle here with angles A and B. So these are known as our reference angles, i.e. we're going to be labeling the other sides from these angles. So I'm going to be calculating sine, cosine, and tan of A, and sine, cosine, and tan of angle B. So first I need to label my adjacent, opposite, and hypotenuse. So I'm going to start with my sine, cosine, and tan. So I'm going to take angle A as my reference angle. So if I go across here, the side that's opposite my reference angle is my opposite, right? So in this case, the opposite for angle A is going to be 6. Then this one here is going to be the adjacent. And then the side that's always opposite the right angle, and the longest side, is known as the hypotenuse. Probably didn't spell it right, but you get the point. Right? So let's have a looky here. So sine A. So sine A, if you look up here, so sine A is equal to opposite of hypotenuse. So there's many different acronyms you can use to remember these. There's SOHCAHTOA. That's one people do be liking to use. So SOHCAHTOA. And that's the one people use. For me, I use oh hell, another hour of algebra, sine, cos, tan. Or other people use Ollie had a handful of apples, which is stupid. Anyway, so let's have a look here. Sine A. So sine A is equal to my opposite over my hypotenuse. So my opposite side is equal to 6. My hypotenuse is equal to 10. So sine A is equal to 6 over 10. Cosine A is going to be equal to the adjacent over the hypotenuse. So that's going to be 8 over 10. And tan A is going to be equal to the opposite over the adjacent, which is going to be 6 over 8. So that's my sine A, cosine A, and tan A. So sine, cos, and tan of angle A. But now, if I look at angle B here, my sides change a little bit, because now if I use B as my reference angle, my opposite side now is the 8. Right, so always remember which reference angle we're working with. If I'm looking at reference angle B, so my opposite side has changed, therefore my adjacent side has changed. But luckily, the hypotenuse doesn't change. So the hypotenuse remains the same, because the hypotenuse is always the side opposite my right angle, and it's the biggest side. So sine B. So now opposite over hypotenuse. So sine B is going to be 8 over 10. Cosine B is going to be 6 over 10 because the adjacent is 6, the hypotenuse is 10. And then tan B is going to be the adjacent over opposite over adjacent, which is going to be 8 over 6. So therefore, I calculate sine, cosine, and tan of angle A and B. So that's when we're given a right angle triangle. Now, sometimes we might be missing a side on the triangle, so therefore we need to use Pythagoras' theorem, which we'll go into in our next example. Now, sometimes here, we are given a trig ratio. So we are given tan B is equal to square root of 5 over 2. And we want to find the value of sine B and cosine B. So how do we do that? Well, first we need to draw a sketch of a right angle triangle. So here's a sketch. I'm going to call this angle B. So tan B is equal to the opposite over adjacent, which is equal to root 5 over 2. So therefore, my opposite side is going to be equal to root 5. And my adjacent side is going to be equal to 2. So my opposite is equal to root 5. And my adjacent is equal to 2. So remember, the opposite is always the side opposite my reference angle here. Okay, so that's great. I have a missing side here. My hypotenuse. So if I want to calculate sine B and cosine B, well, I'm going to need my hypotenuse because my sine B is equal to opposite over hypotenuse and my cosine is equal to adjacent over hypotenuse. I sound really posh when I say hypotenuse. Hypotenuse. Anyway, tangent is up. Tangent aside. Oh, bring it all coming together. It's all coming together. Anyway, so we need to calculate my hypotenuse. And how we calculate my hypotenuse is, well, I'm dealing with a right angle triangle. So I'm going to be using my theorem of Pythagoras. So label my sides A, B, and C. So that's going to be A. That's going to be B. Remember, hypotenuse is always C. So remember my formula, A squared plus B squared equals C squared. So I have square root of 5 squared plus 2 all to be squared is equal to my hypotenuse squared, which I'm going to say h squared. So square root of 5 squared is going to be 5 plus 2 squared is going to be 4 is equal to h squared. So 9 is equal to h squared. Therefore, well, 9 is equal to h squared. Square root both sides. I get my hypotenuse is equal to 3. So hypotenuse is equal to 3. And now we can calculate my sine and cosine. So sine B is equal to opposite of hypotenuse. Well, this is my opposite. This is my adjacent. And this is my hypotenuse. So my opposite is root 5. My adjacent is, sorry, my hypotenuse is 3. So root 5 over 3 is equal to sine B. And then cosine B is adjacent of hypotenuse, which is going to be 2 over 3. And that's it. So they are my two answers there. So sine B is equal to root 5 over 3 and cosine B is equal to 2 root 3. So they are how you could be asked how to find sine, cosine and tan of a right angle triangle. And that, ladies and gentlemen, is me done for this video, and I'll catch you on the flip side. So bye.